So today is a special day for me to introduce Nathan. Nathan has been a student here. He's one of our alumni coming back to give a talk. There's certain special things about Nathan. He took a course with me in 2012 for AM 207 when the course was 12, 13 students. Apparently the course has become much better now, I hear, but it was the beginning. Also, Nathan is an astronomer, so we have that connection too. And then Nathan was one of the first few taking what is called the secondary field in the computational science. Actually, I think it's the second graduating from that with that certificate. And I have this sad and happy moment because of my two roles. I was very sad to find out that he's leaving astronomy because I thought he was one of the most brilliant astronomers we had here at Harvard. Also very happy though because he was moving on to be a data scientist in industry. So Nathan got his bachelor from Michigan State in physics and astronomy and PhD here at Harvard. And now he's a chief data scientist at the WarnerMedia. He leads a kind of diverse team that he has, like people like you, in investigating content and consumers for WarnerMedia. So today his talk will be learning from watching, applying data science to entertainment. And we welcome Nathan.
Thank you so much. Really appreciate the very warm introduction. And it's just such a pleasure for me to be back at Harvard at IACS, to see so many people I know well, and to be able to meet new folks as well. So thank you for having me. So as Pavlo said, I was a student here. I'll talk a little bit more about my sort of path later, but I want to start off just by saying what an incredible influence the IACS program was for me in influencing my career path. It was just a phenomenal part of my time here at Harvard. Hopefully that'll be clear as I talk a little bit more about what my path was and what we're doing now at WarnerMedia. So I thought I would start off by telling you a little bit about our company, WarnerMedia, about our group in Boston, which is called Applied Analytics, and then I'll tell you a little bit about my own path and how I came to where I am. And then I want to end by showing you, first I'll show you a little bit about my perspective on data science and how that carries over into our work. And then I'll show you an example of a project that we think is really interesting and exciting that we're working on right now. So by the end, I'll get to a real sort of hands-on example. All right, but let me start off with what is WarnerMedia. If you don't recognize this name, that's perfectly understandable because it's actually a name that's only been around for a year and a half. So WarnerMedia is the company formerly known as Time Warner. So if you don't know that name either, you might know some of our brands or properties better. So we're a company that produces content. We make TV shows, video games, and films. I'm sure there's nobody in here that loves everything that's on this list, but I hope that all of you love at least one thing that's on here. And of course, this is just a small sample of the thousands of entertainment properties and hundreds of thousands of hours of entertainment that our company has produced over the past century. So all these are individual properties, and they're all organized under a large set of brands that are owned and operated by WarnerMedia. So that includes a bunch of television networks, CNN, TNT, TBS, HBO, Cartoon Network. It includes the picture studio, Warner Brothers, and also its subsidiary New Line Cinemas. It includes streaming services. So right now we have HBO Now and HBO Go. And I'll talk a little bit about what's coming next in a moment. So historically, WarnerMedia was composed of three brands, Turner, which owns a bunch of the cable networks I just mentioned, HBO and Warner Brothers. This is a structure that had been around for decades, up until a year and a half ago. So as I'm sure a lot of you know, a year and a half ago, there was a big change in our company. AT&T acquired Time Warner and rebranded it WarnerMedia. So this acquisition is not only really important for us, but I think it's really a signal event in the entertainment industry. So to illustrate that, here's just a landscape map showing some of the biggest players in the entertainment space. The circles here are just scaled to market capitalization, the size of the company. The color coding is giving you a sense for the domain within entertainment that each of these companies primarily work in. So the purple ones are distributors, internet service providers, cable providers. The green ones are content producers, including Time Warner, WarnerMedia. And the red ones are streaming services that offer products directly to consumers. So I'm sure I don't even have to tell you this, but the plot of the landscape for our industry today looks really radically different than it would have 10 years ago if I was showing you the same picture. So a couple of things that have changed. One, of course, those red circles wouldn't have really been there 10, 15 years ago. Companies like Netflix and Hulu really emerged on the scene relatively recently and totally transformed how all of us, or at least most of us, experience and consume content. and are certainly a signal of where the industry is continuing to go. The other big change is that there have been an enormous amount of acquisitions in this space. So some of those acquisitions are between sort of like companies. So for example, Disney acquired most of 21st Century Fox within the past year. So there's sort of fewer dots on here than there used to be. But the other big trend in mergers is that content distributors have been aligning with content producers. So actually AT&T was not the first content distribution company to acquire a studio like WarnerMedia. About 10, maybe 15 years prior to that, Comcast, the big cable company, had acquired NBC Universal. So it's clearly a very dynamic industry. It's changing really quickly. And for us, that's a really exciting context in which to be doing data science. We really think that analytics and applying data using evidence is an important part of how our company and others can find a future in this landscape as consumers' relationship to entertainment is totally changing and reconfiguring. Okay, so our next big sort of play in this space, the next really big thing that our company is doing is launching a brand new streaming product that's going to be called HBO Max. And actually today, a lot of new information is coming out about that product. So if you're interested in that, I encourage you to check it out. The promise for consumers of HBO Max is that for the first time, all the TV shows, movies, all the content from the networks that I showed you a moment ago are all going to be available to consumers on the same platform. And we hope that's going to be a very compelling offering. So we are, of course, not the only company doing this right now. The streaming space is about to get much more competitive. And I'll talk more about that a little later in my talk. Great. So that's the company. Let me tell you a little bit about our division, which is called Applied Analytics. We are headquartered here in Boston, and our mission, again, is to use data and evidence to help the company make smart, strategic, and tactical decisions about how it creates content. What are consumers interested in today? What are they going to be interested in the future? What kinds of shows, movies should we be making? Also, how we market that content, how we introduce consumers to what we have, both in an advertising context, as that you might get on a social media platform, or that you might see on TV, and also in an engagement context. So if you log on to HBO Max, what content should we be introducing you to? What are you going to be interested in? What's going to keep you a subscriber to the service? We do have a really diverse team, as Pavlos mentioned. So the first thing I want to call out is that, well, a couple things I want to call out. So one is that I'm really going to focus on the work that our quantitative team does within Applied Analytics. Our team is sort of the technical research and development arm of our division. We also work really closely with an amazing team of software developers who help us do data engineering, gather and curate data, and scale up the modeling solutions that we developed to serve the whole company. And we work with a great team of business analysts who help us understand the needs of our partners within the company and the context in which our work is going to be applied. But with respect to the quantitative team, we have sort of two units within the team, and we think it's really strategically important that we combine these two things together. So one unit is data science, and that's mostly what I'll talk about today because that's really where my background comes from. That's exactly what it sounds like to everybody. We also have a team that's dedicated to something that's incredibly important in the space, which is actually measuring, gathering, and observing data. And in our industry, the sort of name for that process of measurement is primary research. So primary research really encompasses everything that involves measuring something that a consumer or a person does. That includes surveys, it includes biometric measurement, it includes even crowdsourced data collection to help us train machine learning models. So we have those two groups together. I also want to call out that we're really blessed to be based here in Boston, to be next to amazing universities like Harvard. And we actually have a lot of really strong Harvard connections. So in addition to myself being an alum, we have two other IACS master's degree graduates who are currently or have been part of our team. So Arjun Sangvi and Victor Lee. And one of our recent team members is also one of the first master's students in data science at the IACS, and that's Phoebe Wong, who's here with us today. So we're really fortunate to be so embedded with the community at Harvard. We try to create a lot of roles in our teams. In addition to our full-time employees, we have a lot of roles for current students and postdocs. We call them fellowship positions. If there's anyone in the room who's interested in getting some experience working in entertainment, please feel free to come chat with me afterwards. I'd love to tell you about our fellowship roles. Okay. So I'll just briefly tell you a little bit about myself, and this will echo Pavlos' kind introduction. So my background is in astronomy. So I studied physics and astronomy at Michigan State University. I came here for my PhD at the Center for Astrophysics, which is on Garden Street, about a mile outside of campus. And it was when I was doing my astronomy research that I sort of learned about computational science and learned about a thing that was relatively new in terms of being branded at that point as data science. So my research ended up being very focused on statistical modeling, and I needed to build those skills. And at the same time, IACS had just created the secondary field program that allowed PhD students like me to get experience in that, experience that you couldn't necessarily get within the context of a scientific department here at any university. So I was really pleased to join the IACS in that capacity and had just a terrific experience. So I went from there to a company called Legendary Pictures, and I haven't mentioned Legendary yet for a reason I'll explain in a moment. But Legendary was doing something incredibly exciting at this time. This is in 2013. Legendary was founded by a visionary CEO who was, I think, fair to credit him as the first person in Hollywood to really recognize that there's an opportunity to use analytics to drive the industry forward and to really base decisions about what types of content to make, how to market it around the types of skills that you're all developing. And so he started our Applied Analytics group. And the reason I didn't mention Legendary previously is that our same group of folks who were involved in starting that group at Legendary were acquired by WarnerMedia last year at the same time as the AT&T acquisition. So our same team is now part of WarnerMedia. So I've been there for 6 years now under a couple different corporate parents. Right. So that's sort of my background. I want to tell you a little bit about my sort of approach to data science that I think is shared by a lot of us in the Applied Analytics group and sort of echoes through our work. So what I'm going to be talking about is also described in a paper that is in the first issue of a new journal that Harvard and the Institute for Data Science is publishing called the Harvard Data Science Review. Today is actually the launch event for the HDSR. So if you haven't heard of it already, I hope you'll be hearing more about it soon. It is online now. There's a link right there. Everything on the Harvard Data Science Review is open access. So you can go check out my article and lots of other fantastic ones that are already published. The great thing about the HDSR is that I think it's really going to be the first forum for data science that's really transdisciplinary, that includes practitioners and educators in academia, in government, in industry, all in the same place, sharing ideas with each other, learning from each other. And even in the first issue, you can see folks like myself in industry trading ideas with folks in academia and beyond. So definitely encourage you to check it out. Okay, so I start off the paper by introducing sort of the most boring, but I think really foundational model in statistical modeling, just a linear regression model. And I'll use this to illustrate the point I want to make. So you all are very familiar with the components of this model. We start out with a bunch of indicator data, observations, measurements that we're gathering, and we're using those ultimately to predict some outcomes. We also have some measurements of the outcome from some process, some dependent variable. So the part of the model's job is to take the indicator data and make a set of predictions. Those predictions, of course, are meant to match the outcome data as well as possible for any given input indicator. And the way the model does that, of course, is by using a set of parameters that are learned from historical data. So we end up learning this vector beta. And when you combine beta and x, you get your predictions y tilde that should match the outcomes y as well as possible. And then we also have a model for uncertainty that's associated with this. So this is all very familiar. And it's not surprising at all that predictions are a very important part of this model. So what does a prediction mean in this context? Well, in the scientific context, it might be making a prediction about the survival rate of a patient group based on historical trends and how different interventions affect different patients. In our industry, we might be interested in topics that are a little different than that. So for example, if we're releasing a new movie, we had a movie Joker come out just a few weeks ago. We might want to know, are our friends going to go to the movie? Is Pablo's going to buy a ticket to Joker? So we can make predictions like that. And this is totally obvious, but predictions are a really important part of business processes. It's really important that we be able to make accurate predictions efficiently at scale so we can integrate them in business processes, including marketing, and to use them to optimize what we do. So I'll just give you a few ideas of applications, how we use this in our context at WarnerMedia. So I'll focus on how we leverage just different aspects of social data and different modalities of social data here. So for one thing, we can do network analysis. We can look at relationships in the social graph, use them to understand what types of audiences are interested in our content or competitors' content, and how that might relate to what you're interested in the future. We can look at another modality, which is images or video. We can use that to understand what of the content that we've put out, the actual films, trailers, creative images, posters that we've put out is really resonating, what types of people are sharing those images, and what are the features of the images that actually are related to really driving people's interest and engagement. And then a third modality is text, looking at natural language and trying to understand from what people say about our properties online, what they think about them, what they're likely to think about properties we put out in the future. And so I'll point out we have a couple nice papers that are cited in the HDSR article from our group on using natural language processing as applied to different aspects of entertainment and marketing. All right. So Clearly, prediction is very important in the data science context. It's critically important in industry as well. However, I think sometimes this perspective can dominate. I think sometimes we get to the point where machine learning actually becomes synonymous with prediction, and people focus on that to the exclusion of other parts of the modeling process. So whereas I think this is sort of a overall balanced view of what the modeling process looks like. This is the linear regression example, but generalize this to any supervised machine learning or really any modeling context. But I think sometimes what people see when they think of this model is this, where predictions are really the whole focus, the sole goal of modeling, and I think this goes too far. So there's another critically important part of the modeling process, which is doing statistical inference, which is thinking about the parameters of the model that you learn from fitting data, what you learn by comparing your model to data. So those are inferences. Those are what we learn about, in this case, the vector beta. So the reason I think inference is important is that I think it really represents how people, decision makers, whether they be researchers in science or studio executives in the entertainment industry, represents what we can learn from data. So it's great if we have models that automatically make predictions and can help us drive business processes. But ultimately, to have a strategic impact, we need to be learning from the model ourselves. We need to be making smarter decisions. Smarter decisions, including things that we do by hand, what contracts we should sign, things like that. But also smarter decisions in terms of how we design our models to make sure that we can improve the both predictive and inferential performance of our models in the future by actually learning from data. So let me focus a little bit more on inference. So the sort of corollary to the two prediction examples I gave earlier in the scientific context, now we're not talking about necessarily predicting the outcome for a particular patient or patient group. Now we're talking about understanding what role an intervention might have had in that outcome. Why did a patient live longer or may live less long? And in the studio context, we want to know why not only is Pablo going to buy a ticket, but why he's buying a ticket, what makes him interested in the Joker, why he's so fixated on that one movie. Okay. So is this true? So I painted this picture where predictions sometimes are dominant in people's thinking about machine learning and data science. You shouldn't take my word for it. We should all look for evidence of this. So in the paper, I go through sort of the simplest possible analysis of this, which I think is really compelling. There's a couple other sort of natural language modeling exercises we go through, but I think this is the one that really tells the story. So what I do is I just take 1.3 million scientific abstracts from the archive. That's most of the archive's subcategories. If you don't know the archive, of course, it's the preprint server where a lot of quantitative fields share their research papers both before and after they're published. So we look through, I think, since 2005, so about 15 years of papers on the archive. And we do the simplest possible thing. We just look for how often researchers are mentioning prediction per se, or synonyms thereof, or inference, or explicit synonyms of inference in the abstracts of their papers. So I'll start off with one example, which is a subcategory of the archive called cs.cv. It's the computer vision section of the computer science part of the archive. And for this one subsection, you can see this trend is really borne out. So the orange line here, which represents how frequently papers are talking about prediction, has grown dramatically, especially since about 2012. And the fraction of papers mentioning inference has been pretty steady throughout that time. And in total, the fraction of papers talking about inference versus prediction, or prediction versus inference, have grown 3 times since 2012, since I was a student in Pablo's class. So I think this is a real trend, and it's quite a dramatic one. And it's not just in the computer vision section of the archive that's happening. So we look at all the subcategories of the archive. Here's a few ones that are probably of particular interest. You can see in the machine learning section of the stats part of the archive, computer vision, the AI section, and the applied statistics section, this trend is the same throughout all of them. But there's been a dramatic shift in the amount that researchers are focusing on this goal of prediction versus the goal of inference. There's one, I think, really interesting exception to this, not the only one, but a really notable one, and that's the theory section of the statistics archive. And that one is actually seeing the opposite effect over the same time period, where increasingly theoretical statistics is focused on inference and not prediction. And there are a few other sections like that. But one thing that the sections that are focused on prediction have in common, generally speaking, is that they're growing explosively. So if you look at the gray dashed line, that's just the volume of papers coming out in those fields. And you can see that the same fields that are talking more and more about prediction are the same ones that have enormous amounts of increased publication and attention. And for theoretical statistics and fields that are more focused on inference, including often astronomy and physics, that trend isn't necessarily as stark. So I think this is real, and the reason, again, I think it's problematic is that if we ultimately in industry or in science and in academia want to be making the most out of the data science work that we're doing, if we want to actually be learning from models, it's very important that we think about both inference and prediction. I'm not suggesting we shift in the other direction and focus only on inference, but I am suggesting that's really important to have a balanced perspective. So let me give you a few applications of what it means to do inference in the entertainment industry. So one is to help us understand our content and why consumers are interested in it. And especially in the context of releasing a new streaming service, this is critically important to us because we have this archive of tens, hundreds of thousands of hours of content we've produced over the past century. And we need to understand what among that content is really going to drive consumer interest in this new product. What is going to get someone to sign up to a product like HBO Max? And what it is about that content that they like. We need to know that to sell the product to them, frankly, but also so that we can create great new programming that aligns with people's interests that really drives their purchasing. We need to be able to model the market at large. So I mentioned before, our market is changing really rapidly and dynamically. We need to be able to build models of that help us infer and learn about the characteristics of that market and how they're changing. I'm going to talk much more about this example in a few slides. And then lastly, we want to understand consumer behavior. We want to know why individual people are doing the things that they do. So I wanted to highlight some work by Victor Lee, who's the IACS alum that I mentioned earlier. He has a great conference proceedings paper that describes what I think is a really unique Bayesian analysis approach to doing attribution. So this is the idea of comparing how and what advertisements a consumer is exposed to whether or not they actually go buy a ticket. It's very difficult to collect the data for this, so we're fortunate to have amazing primary researchers in our group that help us collect that data. But once we have it in place, then we can build these really novel inference models that help us understand how effective is, for example, a Facebook ad versus a TV ad. How is that different across different types of films, different genres, and how has it changed over time? Great. So let me, without further ado, get into the example that I wanted to show you. This is a project that's one of the biggest things that we're doing within our group right now, and I think it's really exciting. And it's all about modeling this changing dynamic market that we were talking about earlier and understanding the role that streaming services are playing in our industry now and in the future. So let me start off by talking about what the sort of streaming market landscape looks like. So this is just a market share plot of the major direct-to-consumer streaming products. There's different categories of streaming products, so you can decide some things belong in this chart or don't, but I think this captures most of the big ones. So of course, there's Netflix, which is really dominant. Amazon Prime has tons of subscribers. Hulu, HBO Now is actually one of the smaller things on there right now. But in the next 6 months, this picture we think is going to look totally different. So I don't know the exact market share of these products in the future, but it might look something like this, where we end up with new streaming products from the biggest companies in our industry, from us, WarnerMedia, producing HBO Max, Apple releasing Apple TV, Comcast NBC releasing their new Peacock service, Disney releasing their new Disney Plus service. The question is really how popular are these going to be? How fast are they going to grow? But I think it's pretty clear that they're going to end up taking a significant amount of the market share in this product space. So we really expect that what happens in 2020 plus is going to look very different than the way the industry looks today. So some of the questions we want to be able to answer, probably not surprising. We want to know how fast will the market share of our product grow? What can we expect it to do after it's released? We want to know how we should price our product. How sensitive are consumers going to be to the price point that we put on it? We want to know how consumers value different aspects of streaming products. So if we have feature X versus feature Y, how much do people care? And we want to know if a consumer were to leave a service, maybe one of the incumbents, how likely are they to move to each of the other services? How likely are they to move to our service? So there's a huge range of modeling goals here, actually. So first of all, there's a bunch of different levels at which this model would apply. So some of these are market level factors. So what is the entire share of the marketplace going to do? Some of these are product level factors. How important are specific attributes of specific products? And some of these are consumer level factors. They have to do with individual people and understanding how individual consumers make decisions. So we really need a framework. Actually, I shouldn't say marketing. I should say a modeling framework that helps us address all these different levels of the problem. And in addition, all of these questions map onto different goals. So some of these are explicitly related to prediction goals and questions that we should be asking of the predictive side of a model. Some of these are inferential goals. So what we were seeking is some kind of modeling solution that could address this whole range of different levels and goals all in one system. So let me describe what we've landed on, what we are building now. we actually combine a few different modeling approaches together. So one is an agent-based model. And just to give me a sense for how much I should describe this, I'm curious, how many folks are already familiar with the concept of agent-based modeling? Okay, so a handful. I think this term is mostly probably used in economics. I think, for example, physicists might call this an n-body simulation, and more or less the same thing. In a lot of other fields, you might call it a Monte Carlo simulation, not so different. The basic idea is that we instantiate a bunch of individual consumers. We call them agents. They have realistic properties like real consumers do. They have a set of behaviors and demographics. They have a history of products they've subscribed to in the past. We capture all that in the model. And then all those agents are confronted with choices during a simulation. So at each time point in the simulation, they're given the option to either keep the set of streaming services they subscribe to or to drop them and to subscribe to something new. So we're really trying to model that choice process and how it evolves over time. And ultimately, what the agent-based model allows us to do is to optimize the marketplace to look like what we want it to look like in the end. So what actions would we have to take if we want our market share to hit a certain rate? What would our competitors have to do for them to be affected in a certain way? But it's not enough just for us to build this sort of forward modeling, agent-based modeling approach. It's not enough for us to just sort of write down the structure of the industry and build that out in a simulation. It's also critically important that we understand what decisions real consumers would make in the context of the market as we simulate it forward. So the approach that we use to that is to use a conjoint model. So let me ask again, because I'm curious, how many folks are familiar with conjoint modeling per se? Okay, so another sort of fraction of folks, and I think maybe a different fraction. I think that's not surprising. But I think conjoint modeling comes out as sort of a different part of the literature, a different part of the academic field than agent-based modeling. Conjoint modeling is used really frequently in market research and in psychology. And it's really relevant here because the idea of a conjoint model is that you expose a real person who's taking a survey to a set of choices. You give them a set of products. You tell them about those products. You say product X has attributes A, B, and C. And then you ask them to make a choice. And there's there's many different variations, different ways you can structure the survey. But ultimately, you're doing a real choice experiment. You're exposing human subjects to a set of realistic market choices, and you're seeing what they do under different conditions. Once you have that data, you can build a model of that data, and the model represents what any arbitrary consumer with those same properties would do if confronted with those same choices. So what we do, of course, is we combine these two things together. So we have the agent-based model that allows us to simulate the streaming service marketplace into the future. And we have the conjoint model that tells us what an individual actor, a consumer, would do at each time point in that simulation. When we combine them together, hopefully, we get a really realistic view of what the future of our industry looks like as new products are entering the marketplace, as other dynamics are changing. So one thing I think it's important to note about this, and I certainly won't be the first person to note this, is that often the most interesting innovations in any field happen when two different ideas are brought together. And we're certainly not the first ones to think about combining an agent-based model and a conjoint model, but it's an area that's not especially well plumbed, I think, because, again, it's really different communities that these two different ideas emerge out of. And so one of the things that's a blessing about our team, and I think a way a lot of data science teams in industry are structured, is that they're bringing people together from very different backgrounds, who come from different perspectives, different experiences with different modeling frameworks, and we find that often there's really amazing things that come out of that diversity and those combinations. So let me show you a little bit about what outputs from this model look like. So I do apologize because I've had to remove the specific product names and things like that, just for proprietary reasons. But I'll show you some real examples of outputs from the model. So this plot is just showing the simulated market share for a few of the key products in the marketplace that we're concerned about and how they evolve over time from the start of our simulation through several years in the future. In this particular model, we're looking at a scenario that's of great interest in our industry, which is called depackaging. So depackaging is the idea that there might be a service provider like Amazon Prime, Amazon Kindle Fire, that allow you to subscribe to other streaming services. So for example, you can subscribe to HBO through Amazon Prime. But if a particular provider were to stop offering our products through their service, if they were to depackage us, that could have a huge impact on our access to the market. It could cause a lot of subscribers to lose access to our service and drop their subscription. So our simulation framework allows us to solve for scenarios like that, see how it would affect our market share, and to build an understanding of what types of consumers are likely to leave in that scenario, and what types of consumers are likely to find a new way to access our product even when that happens. So that's sort of a predictive application. And we can also do inferential applications. So this model has a set of hyperparameters that reflect sort of key features of how the industry works, parts of the industry structure. So the one I'm showing here has to do with how a consumer balances their native interest in a product versus their sort of laziness, frankly, their likelihood to retain a product. So if you already subscribe to HBO Now, and maybe there's not a show that you're watching there currently, but you haven't thought about or don't have the energy to go cancel your subscription, how likely are you to retain it for that basis? So a priori, we don't know where the marketplace in general falls on this line. We don't know if they're more retention-oriented or choice-oriented, but that's a parameter that we can establish in the model. We can run the model under a variety of different scenarios for this parameter, and then we can measure its performance against historical data under each of those parameters. That allows us to do inference on this retention factor to figure out how important it is to consumers, and therefore to help us learn about the structure of the marketplace. Okay. So I want to make sure we leave time for questions, so I'm going to wrap up. I want to leave you with one more thought, which is about a skill that I think we value really highly in our business, and I want to make sure that every student in the room certainly is really thinking a lot about. So that's the skill of science communication. So the reason why I think communication is critical to any scientist, certainly to scientists in industry, maybe even more so to scientists in academia, is that the only value that our work has as scientists is the value that we succeed in conveying to other people. So you can do the best analysis in the world. It can be absolutely rigorous, robust, and accurate. But if you can't succeed in convincing someone else that it's relevant to them, that they should care about it, if you can't convince them that what you're doing is appropriate and that it's reasonable for them to trust your results, then you won't have an impact on your audience. They won't believe you. They won't follow up on your work, and it won't have an impact on the world. So that's why I think science communication is critical. I want to go one step further to say that I think science communication is especially important to one group of people, and that's graduate students. So the reason is that as a society, we should be really concerned about graduate students being excellent science communicators, is that if you ask the question of who does science, especially in the academic context, the answer is not ambiguous. The answer is graduate students are the ones doing science. So this is from the NSF annual Science and Engineering Indicator Survey. It's just a census of who the academic population of researchers are. This probably is not a surprise to a lot of folks in the room, but graduate students outnumber postdocs and faculty by almost an order of magnitude. Graduate students are really the ones who do science. And so if we want science as an enterprise, if we want data science and other scientific fields to have an impact on the world, to influence how people think and to influence our culture, I think it's really critically important that graduate students are empowered to be excellent communicators, both in their workplace and in their conversations with the public. I don't only think this, but I've done my best to do something about it. So when I was a student here back in 2012, a bunch of us who were Harvard graduate students collaborated with some others around the country, and we created a new program called COMSEC, the Communicating Science Conference. I want to make sure all the students in the room know about this because COMSEC is free of charge to any graduate student who's interested. We have events all around the country. We had, I think, 17 events this year, and we're continuing to grow. We have an international flagship event that happens once a year. In 2020, it's actually going to be back in Boston next June. So again, if you're a graduate student, or if you'll be just a few months past graduation in June of 2020, and you're really interested in science communication, we'd love for you to join us there. You can apply. Oh, I thought I had the URL. You can visit our website, comsecon.com, to learn more about COMSEC and to apply. So that's really all I want to share with you. I'll leave the sort of lessons I've talked about throughout the talk here, and I'd love to take your questions. Great. So is there anything that you'd be interested in hearing more about? Yeah.
Can you share which data you use to study subscription price sensitivity, or how you do it?
Price sensitivity?
Yeah.
Oh, yeah, great question. So how do we study price sensitivity? So the approach that we're taking is predominantly through the conjoint modeling that I described. So in the context of a conjoint experiment, you're exposing individual respondents to the option to buy a product at multiple price points. It's a sort of cross-subjects design, so different people are exposed to different price points. And then you're measuring what impact that attribute had on their ultimate selection of the product. So it's ultimately a survey data collection. And therefore, it's really important for us to think about things like how representative is the survey population we're reaching? How quickly is consumer behavior around price changing? Should we collect this data just once? Is it going to still be applicable 6 months from now, or do we need to collect it more frequently? Yeah.
So you came from a astrophysics background,
Yes.
but you are now doing just analytics. So I'm curious about like what's the role of that physical background in your current job? Does that offer you any edge, or do you just use the computational and analytical knowledge? And like, what's your perspective on this, and what's your team's perspective on this?
Oh, yeah, such a good question. So what is the relevance of a specific scientific background like astronomy in the context of analytics and industry? You know, I think there's a bunch of really important aspects to that question. So one is that I think the preparation that you get as a scientific researcher is invaluable in the business context because what you're really doing as a researcher is you're learning how to identify a problem, figure out what data is relevant to it, what types of models to design to solve it, and then ultimately to do all that work. So to go from all the way from experimental design to interpretation, that full stack. And that's a skill set that's incredibly valuable in the business context because businesses sometimes have a lot of data. That's not necessarily their problem, is getting access to data. Businesses often have a lot of business problems. That's not necessarily the problem. Businesses often have really robust technical capabilities in different areas. So not having access to technical skills isn't necessarily the problem. But I think a lot of businesses haven't traditionally hired sort of scientific researchers, people with that background, who can tie those things together. So I think having that experience of leading a research project, understanding how all those aspects are integrated together is super important. The other thing I would highlight is what I mentioned earlier. I think having a diversity of perspectives, having people drawn from different backgrounds, giving them the opportunity to learn from each other and work together is critically important. So I think the fact that I'm bringing an astronomy background to our team specifically isn't necessarily what's critical. But I think the fact that I have a different background from many of my peers and that they're also bringing their own unique perspective is incredibly important to the work that we do. Yeah.
Segue to that question. What other industrial applications do you imagine from this sort of analytics?
Other industrial applications outside of entertainment? Oh, great question. I think the answer to that is truly I was going to say truly limitless. Maybe that's an exaggeration, but I'm sure everyone in the room is well aware that data science has really been arguably the fastest growing segment of industry for several years now. And that's not really reflecting the fact that individual businesses are hiring exponentially. I think rather it's reflecting the fact that different industries are unlocking the potential of data science. So one industry after another has recognized that there's an opportunity for people with backgrounds like everyone in this room to impact their business to have a positive impact. And I think the reason that the growth in job opportunities in the field has grown is because of that sort of cascade of industries. Frankly, entertainment was not early in that cascade. Entertainment was relatively late. There have obviously been industries that are applying the types of statistical research methods that we're talking about decades before ours did. But I think in recent years, it's really sort of cascaded and grown quickly. I'm sure that's not going to continue forever, frankly, right? The exponential growth that we really have seen in data science jobs is not going to continue forever. But I think at this point, it is continuing to grow. And I think when it does level off, ultimately, as of course it will, it'll be at a pretty high baseline. Yeah?
I'm sure that other companies like Netflix and Apple have their own data science teams focused on entertainment. Could you speak, do you guys communicate, and could you speak to their methods and ideas and what they're thinking about? Or?
Oh, such a great question. So yeah, it's certainly the case that other companies in our industry, and Netflix as an example, have invested in data science as well. And in fact, we have some fantastic Harvard alums who I think maybe taught some courses in data science who are now at Netflix. Someone who's a classmate of mine in astronomy who's part of the Netflix data science team is Chris Beaumont. Some folks in the room may know Chris. He's fantastic. One thing that his group does that I really love is that they publish a public research blog, Netflix research blog, which is really a great resource if you want to get a sense for what's going on in that company. I think the next 6 months, because of the slide that I showed earlier, are actually sort of a pivotal time in our, see if I can find it. Yeah, these next 6 months are kind of a pivotal time where, frankly, our companies are going to be a little bit more competitive than they might have been 6 months prior or maybe 6 months later. So I think the level of communication among companies, I think it can honestly stand to grow quite a bit. But there's a lot of folks working in these different data science groups that have personal experience together. We're classmates, have worked with each other at various companies in the past. So there certainly are strong connections there. Yeah?
Hi, so there's been a hope that the internet would provide access to the sort of long tail of very diverse interests in entertainment, for example, on the one hand. On the other hand, one might be concerned that, particularly in the absence of net neutrality, that big companies might be catering to the least common denominator. So do you have any thoughts on that kind of tension?
Oh, that's such a good question. So I'll repeat it and affirm it, which is that I think you're absolutely right that one of the benefits of the advent of the internet and the availability of on-demand streaming services where you can choose what you view. You don't tune into a cable channel and watch what everyone else does, but you choose what you view, is that we can serve a variety of niches in the consumer space. So we can give people content that they want, even if there's not necessarily an 80 million person market for that content. So I think that's absolutely right. I think you're right too that regulatory changes, like for example, net neutrality not being provided in the way that would have been under the previous administration, is a challenge to that. So I don't know what the future of that looks like, to be honest. I think certainly the conversations in our company are focusing around how to take advantage of the former fact and not the latter fact. How to take advantage of the fact that when we're a new product entering an established market like streaming services, it's really incumbent on us to figure out how to connect to consumers, how to make sure they know that we're offering something that's really specifically for them. So I'll tell you, so HBO Max is just sort of being rolled out now. It's not launched yet, so there's not a lot of public information. But one thing that is public that I think is kind of neat is something that's meant to address exactly that. So there's sort of been a backlash that's observed in our industry to how algorithmic recommendations are made on these streaming services. So the two things that we hear really frequently are, one, consumers feel like they're getting a recommendation that's not really personalized to them. It's theoretically based on what they've watched in the past, but it doesn't really feel like it. It doesn't feel like it's successful at finding something they want to watch. And the other is that these algorithmic recommendations, they seem to always promote whatever the featured thing is on that service, whatever the proprietary thing that they've just released is. And that doesn't feel very personalized either. So one approach that our company is taking with our new product release is to offer a feature that we're calling tastemakers. So the idea is that one way for you to find something you like on our service is to say, hey, I've watched that program before. I want to keep watching that program. But another way is to say, hey, I trust this person, or I love this actor, and I want to see what they are interested in. So the idea of this tastemakers feature is that we're actually reaching out to actors, other celebrities, public figures, and asking them to tell us and record a video saying what they like, what are they watching right now, and then that's available to consumers. And that creates, one, a nice feature for consumers. They can go look up the people on this list and find someone they trust. But it's also an interesting data science problem, because now instead of matching just a program to a person, now we're actually thinking about how to match people to people, trying to figure out who you're connected to and who you would trust. And these tastemakers will include everyone from A-list Hollywood movie stars to social media influencers that might have a following of a few tens of thousands of people and really speak directly to a small audience. Yeah.
Sorry, one more question.
Oh.
So given what you just said, and there's so much of what you said that is sort of very consumer-centric. What about being artist-centric? How about applying this to help artists make more money?
That's such a great question. So the question is, it's great to think about what consumers want, but what about artists' creative expression? And you're so right to point that out. It's an oversight for me not to have talked more about that. It's certainly our perspective, and I think any other data scientist in this industry would tell you, that our job is not to dictate to creatives within our company, artists, what people will want or what they should make. But instead, it's our job to inform them, to arm them with information about what the audience is interested in, so they can take the best ideas that they have and figure out how to put them together and when is the right time to put them in front of people. So that ends up being a big part of what we do. It's also really important in the context of communication that I talked about. So if a data scientist goes to present some model result or some learning that we have to someone in the industry who's maybe not a data scientist, maybe has a background or is in a creative role right now, it really doesn't work very well if we come to them and show them the sort of detailed inner workings of the model and the predictions and provide that as instructions for them to follow. It's much better for us to have a real conversation with them, understand their perspective, understand what their needs and goals really are, and then try and support those needs and goals, give them information that helps them make creative decisions. A question?
I was going to ask if you could describe, I guess, what a usual day on your job looks like, if there is such thing as usual, and then also just in general, like, what do you most enjoy about what you do?
Oh, sure. So the question is, can I describe sort of a day in life? So let me ask you, are you interested specifically in understanding like what types of tools and work environments we have, or what what this sort of workplace dynamics are like, or both? Both.
Anything.
Okay. I'll try and hit on all that. So in terms of what a day in the life is like, so we are embedded in this corporate context. So it's really important for us to be able to serve all the partners we have at our brands. So one thing I actually forgot to mention, I'll go back to one slide. Let's see, this direction, yeah, is we are not the only technical team or data science team in the company. There are really amazing data scientists actually embedded in a whole bunch of these different brands. What makes Applied Analytics unique, the way that we're structured within our company, WarnerMedia, is that we're the only data science group that's working across all of the brands shown here. That's sort of what our mission and our mandate is. And so what that means is that we end up spending a lot of time getting to know individual folks on the ground at places like the Warner Brothers game studio and the TNT TBS television network, having conversations with them to understand their specific business problems. Because ultimately our goal is to build solutions that help them individually, but that we can also scale and apply across all the other brands in the company that are facing similar problems. So a lot of our time, especially the folks that are managers and executives on our team, is having those conversations, figuring out what business problems we can apply to and help solve. A lot of our time is also spent really doing new model development. So I think there's maybe a range, a spectrum of extremes in data science. On one extreme, you're maybe very product-oriented. You have an existing solution you're trying to improve incrementally over time and maintain. There's another extreme where you're totally research-oriented. And in that extreme, you're maybe doing a new project every week or every month. You're constantly building new models. You're solving new problems. I don't think we're at either extreme there, but I think we are more on the research side, where we're, maybe on a time scale of every quarter, every few months, we're really tackling a pretty substantially new set of problems. So there are models that we have used for years now and do continue to maintain and develop. But I'd say the balance of especially our data scientist time, is spent on new model development and innovation. In terms of the toolkit that we use, probably like most of the other speakers that you'll see, we're a shop that's pretty heavily invested in Python and in R. We of course use the whole PyLab stack, NumPy, Pandas, Matplotlib on the Python side. One tool that I really think is fantastic that I was introduced to actually through an IACS course, and it's still today, 6 years later, I think one of the most powerful tools in the space is a language called Stan. So I'm curious how many folks have already used Stan in the audience. Okay, just a few, all right. So I'll give you the quick pitch for Stan. Stan is two things. It's one, a probabilistic programming language. So in a traditional programming language, you're specifying instructions that the computer is following deterministically. And if you want to, you can introduce randomness into that and probability by using a random number generator. But the idea of a probabilistic programming language is that you're directly specifying a statistical model. And under the hood, the interpreter is doing all the work of turning that into a probabilistic randomized calculation. So Stan is a probabilistic programming language. It's also an inference engine that has implemented already for you a bunch of really sophisticated optimization algorithms and inference algorithms that help you solve the models that you specify. So Stan's been incredibly useful for us. It helps us rapidly prototype and deploy and do prediction. Say it again?
We moved to Pyro and TensorFlow probability nowadays.
So you're using Pyro. So we're using Stan previously? Okay. Well, I will pass no judgment on that, but I will say that probabilistic programming languages, I think, are incredibly valuable in this field because, again, they help you rapidly prototype models. They help you make changes to them as quickly as you can write down a new equation with a minimal amount of programming. They're great for a data science team. Yeah.
On the slide for market share, I know that's a prediction and it's just a prediction, but I noticed that you didn't have Netflix in the future. Curious to know, was that intentional or?
Good question. So if Netflix wasn't on there, I think it's purely because the PowerPoint had cropped the name. So definitely not asserting that Netflix won't exist. Purely incidental. Yeah.
A lot of industries value speed, and just looking at your example of the agent-based modeling, conjoint modeling, that must have taken a long time to do properly. So how do you think about when you're leading a project, the balance between doing something properly versus the time and cost?
Oh yeah, I mean that's such a great question. So I think that's a real tension that you've hit on that every data science team feels. How do you balance being able to do your best work and building something that you really believe is as robust and appropriate to the problem as possible, with the real business need to get work done and to have answers now, and that really is hard. And I think it's incumbent on on the leadership of any data science team to help the team manage the expectations and really the runway that is allowed for technical teams, data science or otherwise, to do their work. So there's a real negotiation that has to happen there to balance those two different equities, to figure out what the business value and cost is of having something at a certain time, and what the real business value and cost is to, one, having enough time to do it right, but two, having enough time to experiment and not just chase the simplest answer, but to really be able to try a few different things and learn from that process and figure out what's best. So I think a lot of folks in business really look admiringly at the academic model, where there's a lot of intellectual freedom, obviously, and a lot of opportunity to try different things. And we've certainly tried to import some of the best features of that model back into our businesses, and many others have as well. So aside from sort of the prioritization process of figuring out what we work on, a few of the sort of things that we've borrowed from the academic environment that we find really useful. Actually, saw one pop up on my screen earlier. So one is that we have a journal club. So we always want to be keeping abreast of what the most interesting results are from other industry groups and from academia. So we get together once a week. One of our team members presents something that's new in a field. We have a really diverse team, so we end up covering a really diverse amount of topics. That's really useful to us. Even when we're not directly experimenting with something new, we're always learning about something new. The thing that popped up on my screen earlier was the coding office hours, which is really just a time where we set aside for all of us to sit together in the same room and pair code and work on problems together, even people who wouldn't normally be working on the same thing, just as you might do in the office hours for a class. I think we're almost at time. Yeah.
I have a technical question.
Okay.
So when you do the co-join and the agent thing, combine them together.
Yeah.
Is the conjoint model informing the priors for your agent model, or are you doing it? Is that how you do it, or?
Great question. So first of all, I think I forgot to mention that a lot of the work on our conjoint model has been led by Arjun Sanghvi, who's an IACS alum, so I want to make sure to mention that. But the answer to your question is yes. So we are modeling them as a joint system. So when we're doing that hyperparameter inference that I talked about, we're doing that simultaneously across features of the conjoint model and the agent-based model. And to the point about time earlier, so this is expensive both in development time, figuring out how to do that, and also in computational time. So this is an example of a model with an extremely expensive likelihood or posterior function. And so
It's kind of empirical based.
So Bayesian optimization is the approach that we think is ultimately the right one for this, that allows us to, in the context of an expensive likelihood, to sample jointly across different parameter transformations and ultimately find the right answer. So the plot I showed you earlier was showing what happens if you vary an individual parameter in that, independently, but ultimately the way to find the global optimum is something like Bayesian optimization.
All right. Thank you, Nathan, again.
Thank you so much.